Hello everyone. Now we are going to discuss about dispersion in statistics. Now let us see the definition of dispersion. Measures of dispersion are descriptive statistics that describe how similar a data for each other. The similar the scores to each other, the lower the dispersion will be. If there is large difference between the scores, then the dispersion will be high. In general, the more spread out of a distribution is larger than the dispersion will be. Measures of dispersion. Before here, let us see which of the distributions of scores has the highest dispersion. The upper distribution has more dispersion because the scores are more spread out. That is, they are less similar to each other. In the first graph, there is more dispersion because the similars are very having huge difference between them, whereas compared to the second graph, so the dispersion will be less compared to the first graph. There are three types of dispersion. The first one is range. The second one is semi-interquartile range. And the third one is variance or standard deviation range. Let us see what is a range. A range is defined as the difference between the largest score of set of the data and the smallest score in the set of data, where XL represents the data which is larger in that set and XS represents the smaller data in that set. Here, let us see what is the range in the following data. Here, the largest element is 9 and the smallest element is 1. So, the range is 9 minus 1, that is 8. When to use range? Let us see the applications of range. The range is used when you have the ordinal data. You are presenting your results to people with little knowledge or no knowledge of statistics. The range is rarely used in scientific work as it's fairly insensitive. It depends only on two scores, the set of data, that is the larger data and the smaller data. Two very different sets of data can have the same range. Here, there are two different sets. This is 1 and this is 1, and here the range is 9 minus 1 equal to 8, and here also the range is 9 minus 1 equal to 8. Semi-interquartile region is defined as the difference between the first quartile and third quartile, and they are divided by 2. The first quartile is the 27th percentile, and the third quartile is the 75th percentile, and semi-interquartile region equal to half of the Q3 minus Q1. When to use it? The SAR semi-interquartile range is often used with skewed data as it is insensitive to extreme scores. Variance. Let us see what is variance. Variance is defined as the average of the square deviations, and the formula of variance is sigma square equal to sigma of x minus mu whole square by n. What does the variance formula mean? First, it says subtract the mean from each of the scores. This difference is called deviation. The deviation tells how far the score is from typical or average or score. Thus, the deviate is measure of dispersion for a given score. Why can't we simply take the average of deviates? That is why it is not variance defined as. This is not formula of variation. One of the definitions of the mean was that it always made the sum of the scores minus the mean equal to 0. Thus, average of the deviates must be 0 since the sum of deviates must be equal to 0. To avoid this problem, statisticians square the deviate score prior to averaging them. Squaring the deviate score makes all the square scores positive. Variance is the mean of square deviation scores. The larger the variance is, the more the scores deviate on average away from the mean. The smaller the variance is, the less the score deviate on average from the mean. What is standard deviation? When the deviate scores are squared in variance, their unit of measure is squared as well. For example, if people's weight are measured in pounds, then the variance of the weights would be expressed in pounds square. Since squared units of measure are often awkward to deal with, the square root of variance is often used instead. The standard deviation is the square root of variance. The formula standard deviation equal to root or variance and variance equal to standard deviation whole square. The computation formula. When calculating variance, it is often easier to use a computational formula which is algebraically equivalent to the definition formula. Sigma square is the population variance where x is score and mu is the population mean and n is the number of scores. Here given data x, they give the data given as 9, 8, 6, 5, 8 and 6 and square of this data is given. We have to sum up all these and mu equal to, we have to find out the mean value and subtract the mean value from this and we will get the summation of deviation square equal to 12 and sum of deviation equal to 0. So formula is given as from the before data and the variance is 2. Because the sample mean is not perfect estimate of the population mean, the formula for the variance of a sample is slightly different from the formula for the variance of the population. That means the data minus the mean of overall data whole square by n minus 1. S square is the sample variance where x is the score and x bar is the sample mean and n is the number of scores. We want to know about the skewness. If the tail is skewed to right, then it is positively skewed. If the tail is not skewed to any other either side, either right or left, then it is called as normal skew. Then the skew value is 0. If the tail is skewed to left, then it is called as negative skew. A skew is measure of symmetry in the distribution of scores. The formula can be used to define the skew. If the skew value S cube is greater than 0, then the distribution has positive skew. If the skew value is less than 0, then the distribution has negative value. If it equal to 0, then it is normal skew or it is symmetrical. The more different S cube is from 0, the greater the skew of the distribution. When it is normal skew, then it is, if it is peaked, then it is called as leptokurtic and it should be less than 3. The kurtosis value should be less than 3 and it should be sharp edged, and if the kurtosis value is equal to 3, then it is called as mesokurtic. And if the kurtosis value is less than 3, then it is called as platykurtic. Kurtosis measure whether the scores are spread out where more or less than they would be in normal Gaussian distribution. When the distribution is normally distributed, its kurtosis equals to 3 and it is said to be mesokurtic. And leptokurtic we have already discussed, and platykurtic. And this is the formula for S to the power 4. This is the measure of kurtosis. The relation collectively, the shape of the distribution. This describes about the shape of the whole distribution. Thank you.